Hello, everyone. My name is Noman Mohammed. I'm a senior DevOps engineer working for Fortune 50, 50 companies in the United States. I have been working in a telecom industry for like period of like 5 years, and I have around a decade of experience in cloud computing. Today, I would like to present about Ignite native solutions, Apache Ignite, and Kubernetes in action. Let's begin. Uh, Today I'm going to introduce about Apache Ignite and the key points and what are the features of the Apache Ignite. So basically, Apache Ignite does have an in-memory distributed database and catching platform, which is the highlight and the deal breaker in the current cutting edge technologies. And the second key point is high performance and low latency data storage. This is one of the most important features which need to be considered. The following features does have its distributed SQL, ACID transaction, clustering, and fault tolerance. Moving on the use case of the telecom industry and why did we choose the Apache Ignite in the telecom? Because of the high performance demands, need for real-time subscriber data processing, and followed by the latencies issue, which is the most common in the application if it is on the legacy system. So that database struggle under high workload does cause latency. The another point is the scalability concern, which is really used to scale up when in demand traffic required. The other followed by is resilience requirement. So downtime lead to lots of revenue and poor user experience, which is the most important for any organization. So before we used to had a Redis due to and which we faced a numerous disadvantage. One is lack of distributed SQL support, and the other one is inability to handle ACID compliant transaction. ACID compliant is a very important for current application in order to be more efficient and effective. That is the most important feature for any database should have. And the followed by the last one is high maintenance cost due to manual shedding. So now I would like to describe about the key difference between Apache Ignite and Redis and why we choose Apache Ignite over Redis. So main feature which I would like to go in detail is primary use case of the Apache Ignite is in-memory computing database caching, where Redis does have key value store caching. So Apache Ignite does have income in memory. It means that it does require a faster performance if it has a in memory. So the data, so that if we run a query, it doesn't have to go to the disk, rather than the in memory does have the feature where it get the data for the user. So we make the performance much better, whereas the Redis doesn't have that feature. The other followed by is persistent. So Apache Ignite support durable storage, whereas Redis doesn't only support snapshot and AOF persistence. For the SQL support, Apache Ignite does have full support SQL queries, and Redis does have a limited SQL-like feature. So Apache is better in this particular feature as well. And coming to the transaction support, Apache Ignite does have the ACID transaction, whereas the Redis does have the atomic operation but no full ACID support. ACID transaction is a transaction where if we are trying to get a full transaction, if any operation get failed, then the database doesn't execute the entire flow. So which is the really important to reduce the failure issues when if we fail any failure operations. So the other feature followed by is the scalability. So the Apache Ignite does have a horizontal scalable options where Redis doesn't have. And the last is the machine learning. So Apache Ignite does come with built-in ML machine learning capability, so which is the most popular and the hot buzzing word in the current scenario. And if Apache Ignite have this feature, then it is really useful for the company to enable the ML capabilities. Now, as I mentioned, like in the previous slide about the difference, so why we choose Apache Ignite over Redis? Because we had faced challenges while we implemented the Redis in our application. The first and foremost was the required extensive manual shredding, because due to the because due to no scalability options, and because of the poor performance, we had faced numerous issues. The other was the lack of support for complex SQL queries. So real-time scenario required complex queries, and when it comes to real-time situations, then Redis was not able to fulfill organization requirement, whereas the Apache does have this ability. And the followed by it doesn't have the ability of AC transaction, which I mentioned in the previous query, previous slide, which how what are the importance and how it affect the organization overall. So when Apache Ignite comes with a numerous benefits, and the most important one is listed here, which is seamless horizontal scaling with Kubernetes. Kubernetes is one of the orchestration tool for container organization, orchestration for container microservices, and it support horizontal scaling. And also Apache Ignite has ignited integrated machine learning and real-time analytic, also support SQL queries, and it has a resilience in memory data grid for faster transaction. So does have it always been in most of the lot of situation, which make it more attractive database. So now the point is why Kubernetes for Apache Ignite. My expertise is I'm a senior Kubernetes DevOps engineer, and I have implemented Apache Ignite for my team. And Apache and the Kubernetes is the most popular tool currently for orchestrating container orchestration microservices. So the first and foremost is automated deployment and lifecycle management. Kubernetes as a tool has an ability which enable declarative infrastructure, ensuring Ignite cluster can be deployed using infrastructure as a core principles. And it does is very easy YAML based configuration, which allow modification, version control, and replication across environment. So the deployment is really easy, and it is scalable. The second and foremost is the elastic scalability and resource optimization. So Kubernetes has HPA, which is the really important, and the most important element here is horizontal pod scaler, auto scaler, which ensure Ignite scale dynamically based on the CPU memory consumption. It allow efficient utilization of underlying compute resource, preventing over provisioning. So optimization is important for organization cost to be optimized. And the followed by the container orchestration and self-healing. So the Kubernetes does have a following benefits, like it has orchestration, container benefits, and self-healing. So if any pod restart happen, then the mechanism of the Kubernetes will restart the pod automatically without any manual intervention. And it has a node failure recovery. And the last one is the self-healing mechanism, detect an healthy pod and reschedule workload on healthy nodes. So that mechanism of the Kubernetes make it more interesting. Now, why Kubernetes for Apache Ignite? It has a synergy for the Ignite distribution. It has a restart stateful set with persistent value, ensuring Ignite node retain identity and data across pod restart. It does have the following other seamless integration with cloud native ecosystem, where we can have implement monitoring using Prometheus and Grafana, provide real-time visibility into Ignite cluster performance. We can also implement STO service mesh, enhance inter-service communication with observability and traffic management. So these all cutting-edge tools, technologies can be seamlessly integrated with the Apache Ignite. So what are the real-world Apache Ignite implementation in Kubernetes? So in the telecom world, we handle millions of telecom subscriber records in real time. So it reduces query latency from seconds to milliseconds for a faster performance, and followed by ensuring zero downtime during system failure, because it has a capability to to recover from the fail node to the to the node uh, which is in a working condition. So what are the technical component? It has an in-memory data grid for high-speed transaction, Kubernetes for auto scaling and failover, integration with Kafka, and traffic management, which I earlier mentioned in the previous slide. Now, what are the deployment strategies and what are the detail I would like to describe about the detailed walkthrough of YAML configuration in this slide. So I will be going to describe about the step-by-step deployment of the Ignite in Kubernetes, how we use stateful set and config map, how the network separate with Ignite IP Finder will enable through YAML, how the pod resources limit and request is required, and how we enforce it through YAML, and how the persistent storage will achieve. Why we configure it this way? Because to ensure higher availability and stability, which every organization does require and does want, it is a number one criteria, and it has a priority list. The second one is the optimized resource allocation to prevent bottleneck, and followed by the maintain data consistency during scale in and scale out events. Because we are dealing with database, if any scale out and scaling of the pods are happening, then we have to ensure that data consistency is also restored and maintained. Now, auto scaling Apache Ignite. Why auto scaling? Because we require to handle unpredictable data spike. In the current world, not every time the traffic will be same. There will be a particular time where the traffic is exponentially grow, and for that we have to handle the application. How can we achieve that? Through Kubernetes. And how, what are the elements which use in the Kubernetes is HPA, which will enable the application scale in and scale out depending on the unpredictable traffic spikes. And also it has a node discovery, maintain cluster consistency. So these are the features where Kubernetes will help Apache Ignite to auto scale. What we learn from the lesson: avoid excessive scaling to prevent unnecessary data, optimize rebalance thread pool size to control resource consumptions, and the final one is the implement partition affinity to avoid data loss locality issue. Uh, Now, YAML manifest for deploying Apache Ignite in Kubernetes. So we have a following approach where we can able to write in the YAML file in the Kubernetes. So here we are implementing headless service for Ignite. So headless service doesn't require any IP. Through the labels and the through the labels here which is mentioned, we'll be able to discover the services. So I'm here to show how I define services in the YAML. So API version is the v1 in the, and the followed by the kind, we have to define the services, followed by the metadata which is required for that cluster to associate or to get the relevant data, followed by the label. As it is headless, so we have to have a label associated to it so that it get help for service discovery. And the spec is cluster IP. Since headless service doesn't have any IP, so it does not have any IP here. So we have to have a selector at the same time. So we have used the app Ignite here, and for to make sure that all the services are connected to the ports and the to the protocols, all these descriptions are listed in the YAML file. Now we also use stateful set for Ignite. Stateful set are comes useful when it is dealing with the database. If it is non-DB related application, web service or app, then stateless objects will use kind is used for Kubernetes manifest. Here we are using stateful set. Now we are defining the replicas, how many replicas which needs to be which need to be using in the cluster, and what all required ports here, what are the Apache Ignite, how many seconds that pod need to be take place to restart, what are the ports, and how many name of the services, all are listed in this YAML file. The other slide is the continuation of the previous learn. So we are also describing about the volumes which are associated. So where, what is the name of the volumes, where are the config maps, and what are the parameters and environment variables are associated in that. Also we use HPA, which I mentioned that HPA is the most important horizontal pod autoscaler. So we have to describe in the YAML file that how many minimum replicas and maximum replicas we require. We don't need to go beyond 10. So for example, so we describe the limits here, 3 and 10. We also describe the metrics and what are the things which we going to ensure that that HPA will work. So here we are using CPU, and the target average is 70%. So if it goes beyond 70%, then the HPA kicks in and it auto replicas will keep adding pods to the cluster. So the limit over here is 70 CPU. So ideal scenario, the 85% is what most of the organization take, but here we take 70% to ensure that we are not go beyond our limits. So how it work, as I mentioned in the previous YAML file. So it's all about the request and limit which describe in the YAML, and how CPU will use is because if it exceeds 70%, then the replicas keep adding. So if the CPU drops 70%, then scale out will happen and it will go back naturally to the minimum limit, which is 3 replicas. So how we optimize Ignite in memory cloud computing for cloud, since all the infrastructure are being hosted on the various cloud services like Azure, GCP, or AWS. So but for most of the cloud services, the functionalities are pretty common. So for in general cloud, we have to ensure that when we deploy cluster, it should be multiple availability zone. So if any availability zone is not available for whatever reason, then the other availability zone will be act as a backup, the and the and it is always have a higher availability to ensure availability and uh, always uptime is maintained. And the second strategy, we have to ensure that it implement backup strategies using Ignite, WL persistence, and fault tolerance topology to prevent data loss. So what are the strategies for cloud native? Utilize Kubernetes native storage solutions. So I mentioned it previously in the slide. So it has that capability to make that application always up and running through its mechanism and strategies. Does it hold as a technology? The second one is implementing auto tuning mechanism through which we regulate heap and GC optimizations, and also use Ignite snapshot capability for rapid disaster recovery. So this is very important functionality to make sure that if any disaster happen, then it can be able to recover through snapshots. What are the practical tips and tricks for deployment Kubernetes? Since Kubernetes is a very complex technology, it required so much of uh, uh, you know supervision, and a lot of things are required when it comes to scaling all the pods and nodes and all those objects associated to it. So what are the common pitfalls and how to avoid it? We have to ensure that pods should not restart uh, always. Like, we have to avoid the restart. We cannot stop it, but we have to minimize it. So what are the features we implemented here is health check and resource limit through the manifest file. We also optimize rebalances setting to prevent performance bottleneck and provide configuration transactional cache memory for consistency. We implemented security best practices like RBAC roles to unauthorized Ignite access and enable TLS encryption for inter-node communication, implementing auto audit logging to track cluster activities, which are the best practices for the security purpose. And the recommendation which I can give you is use Kubernetes operator, and also make sure that it always have a monitoring tools like AI driven or other various tools like Prometheus, Grafana, which we'll talk in future. We also have to ensure that test disaster recovery plan to regularly with fault injection simulation to ensure that if any disaster recovery happen, then we are planning and we have a proper roadmap to recover from the disaster. So as we mentioned, that all the practices that we have to enable in Ignite persistence, partition backup, useful setup, monitoring resource using Prometheus and Grafana to track CPU memory usage and scale. And also most important is rebalance thread pool size to ensure that the prevent performance degradation and preventing right scaling strategies. What are the optimizing Ignite for cloud computing, cloud environment? As it has to be a replication backup, node discovery, and Kubernetes IP Finder. It also has to be a disaster recovery, multiple zone snapshot. So what are the common pitfalls and fixes? So if pod fails due to out of memory issue, then the solution is to set proper memory limits and request in the YAML file, which I showed previously. And also the another issue which we most commonly face is Ignite nodes not discovering each other. So we have to use headless service, which I showed in the previous manifest file, how we use the headless parameter in the YAML file. And the another one is scaling issue with scaleful set. So we have to implement HPA, which I implemented in the previous slide, followed by the performance degradation over time. So we have to monitor JVM garbage collection and optimizing settings through various monitoring tools to ensure that we are getting rid of unnecessary garbage, which we to ensure optimization of the system. So best practices for Apache Ignite Kubernetes. We have to ensure the partition backup, optimizing rebalancing, and affinity rules help optimize workload distribution. Affinity rules is something where if someone is client is trying to connect to the particular server, then the affinity rule will stick to that particular session, and it will complete until the transaction is completed. So what are the monitoring Ignite clusters? For the monitoring tools for clusters, so we can use Prometheus and Grafana for metric, where we can able to get all the information of the cluster, which is displayed on Prometheus, and Grafana is the best description of a visual representation of entire logs. So this is most popular tools which in our organization we have used. And we also use logging with fluentd. It collect and get all the data from the cluster, and it will load it to the elasticsearch and kibana. And another which I recommend is the Ignite Web Console for real-time clustering, which also has the same capability and have a better performance. What are the lessons learned when we deployed in the Kubernetes cluster? Is avoid excessive auto scaling. So we have to ensure that the frequent pod restart impact query performance. So manifest file has to be described in such a way that it will take care it will take care everything without prop access restart, and has to have a proper partitioning strategy for essential balancing load across Ignite nodes, followed by fine-tune rebalance thread pool size. This is very important, as if we thread pool will ensure that how distributed data get transferred, and to optimize the performance of the system. It also has a monitor Ignite SQL performance to avoid slow queries in high load environments. So this all comes a major significant to the performance of the system. In the conclusion, why we use Apache Ignite plus Kubernetes: to deliver high speed, resilience, and cloud native database, scale seamless without compromising performance, ensuring enterprise grade and support highly distributed and high performance architecture. So as I am from the telecom background, and I have almost like a more than 5 years in the telecom industry and work for Fortune 50 companies in Fortune list. So what I have tackled and what we have achieved through implementing Apache Ignite is what I am going to describe here in the use case. So when we implemented Apache Ignite in in the telecom environment, was our first objective was to enhance real-time analytic caching and network optimization. So one of the main primary concern was the real-time caching for subscriber data management. And the challenges which we faced was high query latency when fetching subscriber profiles from traditional database. So when we implemented Apache Ignite in-memory data grid to store customer profile, it reduced backup lookups, and the outcome was 99.99% availability and 3x faster query response, which is a significant and huge uh, performance improvement in our environment. The other issue was call data record processing and fraud detection. So the challenges was millions of call data records in real time to detect anomalies, which are always a concern for any organization. So for a solution, we implemented Ignite distributed SQL process CDR in memory for fraud detection. What are the outcomes? It significantly improved the performance. It detect almost fraud activities and detect 30% faster than the previous system. So it's a huge benefit to our organization. And the third was the network performance optimization and edge computing. So the challenge was the handling massive IoT data stream for 5G network optimization. And we implemented solution at the Ignite collected processing, allowed low latency edge analytics, and the outcome was extraordinary. And we reduced network congestion and improved QoS, quality of service, by 25%. And the final was the real-time customer insight and billing optimization. So we were facing the challenges of traditional billing system cost, delayed in generative invoice, and the solution was Ignite stores session data and transactional logs in memory, optimizing billing cycles. So the solution was we implemented transaction log in memory, and the outcome was billing latency reduced by 40%, improving customer experience overall. So this is a huge benefit to the organization when we implemented Apache Ignite in various other use cases, and it has significantly improved the performance to exponential way. And the previous system and the current system made a huge difference, and it satisfy overall to in every aspect. So why Ignite over Redis for telecom? So the telecom does have where, as I mentioned, but here the more detailed version is in memory caching, where Apache Ignite does fall yes in every category. So distributed SQL, ACID transaction, persistent storage, machine learning, compute, in every aspect Apache Ignite win in every possible situations. So all this integrated with Kubernetes, hyperscale, in memory, and distributed are the key advantage of Ignite in telecom industry. So here is the end of the session, and I would like to welcome the participant to have a Q&A session, and let's ignite the discussion.